Hi, welcome back. So in the previous class, we have seen the importance of network and the transport layer. We have understood the difference between the OSI and TCP. I hope you have done your assignments. And just moving on, we'll directly jump into a simple daytime client program. So in this program, I just want to explain how a network program is written. Okay, maybe at the end of this session you might not understand each and every function that has been used in this program, but yes, this program is intentionally given to you in the first class so that you understand what is the outline of a network program, what is the basic components that are required to write a program for networking. So we'll directly start with the program. Will come with the first line. So as you all know, any C program will always start with the hash include statement, and the first one we are starting with is unp.h. And what is this unp.h? If you start searching in a C compiler, you will not get any information on this, because this is basically a user defined header file. Okay, so this user defined header file, what does it contain? It has a list of all the system headers which are required for running a network program. And basically this is hidden from you. What are all the system header files that are required? It is hidden right now, and it is all put into one common header file called unp.h. So basically, not to create a lot of confusion in the first few stages itself. Okay, so the thing is, I am having the header file, the set of header files required for network program, and it also has some set of macros. Okay, then moving on, we have this command line arguments. So we all know how to what is a main function. So in any program for that matter, especially C, C++ or Java, main function is the first function from where the execution starts. And if I want to pass arguments to this main function, then we'll have to pass those arguments as command line arguments. So, and that is given at the time of execution of the program. So whenever you call the program for execution at the command prompt, I will pass the arguments there. I think you might have experience of writing some simple programs using command line arguments. So we'll discuss on that in detail later. So the next set of instructions which I want to highlight here is the line number 10 and 11. Okay, that is we are using the socket function, and we are using some variable called sockfd, and there is a function called error sys, that is err underscore sys. So what you can see here, so I'm just pointing it out. So as a socket is one function, we have a variable sockfd and error sys function. What are these? I will come back to line number 7 later. So first we will go through what is this. So here I am calling a socket function. So what is this socket function, and what is socket we will discuss in detail about it later. But right now what we will have to understand is we have to use a function called socket if you want to write a program in networks. So what is this socket? So the socket function creates an internet stream socket. So basically socket function, if I want to establish connection between the two machines, then I need to have a socket on both the ends, and these sockets will communicate with each other, or it will help in establishing a connection between the two devices. So that functionality of establishing connection is done through socket, and without socket I cannot establish the connection. So how to establish this, how to create this socket? By using the socket function. So the function returns a small integer descriptor. So whenever I call this socket function, if a socket is created, it will return a positive value. And if the socket function returns any positive number, which any negative number, it means establishing the socket was not possible, and that leads to an error. Okay, so whatever socket function returns, whatever integer value it returns, that integer value I am storing it in this sock fd. This is a normal integer variable which talks this name is given for its meaning, that is socket file descriptor. So this is an integer value. So if this socket fd is a positive value, I'll be using throughout in the program wherever I need to establish a socket or use it for communication purpose. But if this socket fd has a negative value, it means socket creation there was an error while creating a socket, and hence I am going to display some user defined error message like socket error or socket could not be created. Some error message will be displayed, and to display the error message you might say I can use a printf statement or something like that. Yes, but we want to define different types of errors. So for different types of errors we have a user defined functions. So if it is a system error, I will call a function called error underscore sys, and this in turn will call the printf statement, and this socket error, whatever is the user defined error message, that will be passed as a parameter and that will be printed. So this will help me to understand what type of an error it was. So it was a system error. Now moving on to this line number 7. So in line number 7 we are defining a variable called servaddr, which stands for server address. Okay, so it means this variable should hold the address of the server. But what is the data type of address of any machine? We don't know. So that address, the address definition is defined in the structure called sock address underscore in, that is socket address internet. So this is the structure name. So hence it is called struct sock address underscore in. So this structure actually defines how the address of any machine should be, especially in computers. Okay, so what this structure has, that we will see later. What are the members of this particular structure? And here I'm declaring a variable. It is just like we are declaring an integer variable. If I say int a, then a is a variable which will hold integer type of value. Likewise, here server address is like a. So this is a variable which holds the data of structure sock address underscore in type. So it will hold the socket address type of data in this particular variable. I hope you have understood this structure. So what is that we have learned in the first part of this program is we have some set of header files which are required for network programming. Then we are dealing with the main function which takes command line arguments. Then we should know what is the structure that is used to hold the addresses of the different machines. And then we have understood the function that is required to create a socket, and what type of value it returns and what is the meaning of that value. So this we have studied in the first half of this program. In the next half of the program, we will again highlight, I'll highlight some of these lines. The line numbers 12 to 16. This is also a very important concept. So here we are using a B0 function, and we are also using some some of the other new names, the nomenclatures, which you should remember for the rest of the course and maybe in the rest of the career also, so that it helps you in building a better career in networking. So you should know all these things. Okay, so what does this line number 12 to 16 tell? So here so server address we have seen in the previous first half of the program. Server address is a variable of structure type. What am I doing with that? I am passing that server address variable to a function called B0, and I'm also passing the size of that particular structure type. So what does B0 function do? So B0 function, again, it is a function that is used to assign all zeros to this structure variables. Okay, so whatever this structure has, whatever members it has, all those members will be initialized to zeros. And how many zeros? That depends on the size of that particular structure. So for this particular size, in this particular variable, all the members of this structure will be initialized to 0. So that is the function v0. And server address syn family, server address syn port, and server address syn ADDR. Okay, so wherever I'm talking, I'm pointing here are all the data members. See here, syn underscore family is a member of server address, correct? Server address is a structure type. So it means syn family is one of the members of that structure. Similarly, server address dot syn port. So it means syn port is also a member of the structure. And here syn address, this is also a member of the structure. Okay, so what are these? So server address syn family, I am assigning AF underscore INET. So this is a predefined macro. So AF underscore INET will tell what type of data streaming is required in this particular program. So AF underscore INET stands for the TCP type of streaming data. We will understand what are the different types available. But what I'm trying to tell here is this structure requires the type, the family, what type of streaming is required. So that is required. So I'm specifying AF underscore INET. We will understand more on this later. And then syn port, what does this port mean? So the port tells which port number I am assigning to the syn port, to the server, because without server's address I don't know, I cannot establish the connection. So I need the server's IP address and I also need the server's port number. So which application or where exactly in that machine you want to transfer data or send a request. So I am telling port number 13, and port number 13 is a well-known port which is basically supports this daytime type of simple service or applications. So I'm using port number 13, a well-known port. So what is that we are understanding here is, in the structure we need to specify the type of streaming required, we need to specify the port number to which you want to communicate on the server side, on the server machine. Okay, so these two things are required. And then here I am assigning syn address. What is the address that I have to store in this server address? So server address dot syn ADDR stands for the address, the IP address that has to be stored. What is the IP address that I'm storing here? That is passed using the function inet underscore p2n. Okay, I'll tell you what is p2n and h2ns later. So this AF underscore INET is the family type. ARGV1, as you know, ARGV is the value or the parameter that is passed as the command line argument. And what is the value that I am passing? I am passing the server's IP address. So to which server you want to communicate, I'll have to specify the IP address of that as the command line argument. So this command line argument will hold the IP address of the server, and that IP address of the server and the family name is assigned to this server syn ADDR. So this is the source and this is the destination for the function inet p2n. Okay, h2ns, what is h2ns and what is p2n, we'll study that in detail later. So p2n stands for presentation to network, and here h2ns stands for hyper. Okay, I'll just let you know that. So h2ns basically it converts the port number or this IP address. Basically, what are these functions meant for? These functions are meant for converting any user defined or user understandable format into the system or machine understandable format. So if I say the IP address is passed as 192.168.12.4045 or something like that, that is the dotted IP address, IPv4 format, but that is understandable by human beings. But at the network layer, how it has to be understood, how does the machine, how I make the machine understand this IP address, that is done by P2N. Okay, so this P to N and H to N, basically they are meant for that. So if there is any issues, for example, in converting the user format into machine understandable format, if there is any issue, if there are any problems in converting, then I am calling another user defined function to quit the program, because when I am unable to convert the address formats, then there is no point in moving further. So I am calling the err underscore quit function, which will again display this particular error message, saying that this IP address is not reachable or something like that, and then I will quit the program. Now if it is success, that is if it is not a negative value, then I will uh, continue with the communication. So once the socket is established, then what we do, we call the connect function. So here in the connect function, basically I am connecting the server address, and server address is already assigned here. So this server address has to be connected. So to connect, I call the connect function. I am using the sock FD, that is the integer value which is returned by the socket function. And this SA, don't get confused, this is the socket address only. So this is a macro which is used to shorten the name. Socket address was a big name, so it has been shortened as SA. So it acts like a macro, and this will be used for type conversion. So whatever server address I am passing, that will be converted to the server address type. And what is the amount of data that has to be transferred, that is given by size of server address. So if I want to establish the connection using the connect function, the connect function will also check the value, and if the value is less than 0, it means connection could not be established, and I will call the function again a system error. So err underscore sys, and I will display a message saying that the connection could not be established. So if it is greater than 0, or if it is a positive value, then I will continue with the connectivity. Then coming to the next set of code, that is I'm using while loop. Now this is a little confusing, because you might ask, why do we need a loop? Because I'm sending a request to the server, and server is sending the date and time, and I'm getting the date and time. What is the necessity to have a loop? So this is pretty a very good question for us to answer this, because we will get to know about TCP better. So this is an example of a TCP program using a TCP protocol, and in TCP usually the socket address, the size of a socket address is set to 26 bytes, which can be configured, but otherwise what happens here is the TCP is they use the byte streaming. So it means if this is a 26 byte data, for example, if it is returning some data like Monday, July 20th, along with some time, then that entire data, if I consider it as a 26 byte stream, then I might get that entire 26 byte stream in one shot, in one segment, or I can get 26 segments of 1 byte each. So I will be getting 1 byte at a time, or I might get 5 bytes at a time, or I might get all 26 bytes in one single shot. So I don't know exactly when will it terminate. Okay, so in that case I'm using this while loop. Okay, so what does this while loop tell? This while loop is used to receive all the segments from the server, and once the server sends the close signal, once the server closes the connection, then a negative value is received, and then that negative value will help me in terminating. So here this loop will continue until the value that is sent by the server is greater than 0. So if it is once the server closes down, it sends a negative value, and then this loop will terminate. And whatever data is received, that is received using the read function. You can see here read function. Read function is used to receive from the receive line, and whatever receive line is there, receive line, it will whatever is been received, I'm storing it in receive line, and that receive line I'm going to display on the standard output device using fputs function. So fputs, it relates to the file input output. So until it reaches the end of file, whatever data is received, it will display that using fputs function on the standard output device. And if there was any error, then automatically if it will display fputs error. Okay, so that is how, and once the next set is the exit function. So in this exit function, what happens when I call this exit function, whatever process is been running, that will be closed on a Unix machine. And whenever a process gets closed, all the file descriptors which are open, they also automatically get closed. So what happens, whatever socket address or whatever file descriptors are open, all of them will be closed automatically whenever I call this exit function. So that was a sample about this simple daytime client, and this particular program works on IPv4 addressing. So here, in the entire program, I was using IPv4 as the version of address both for client and server. So in the next class, we will discuss more on the same program, and we will try to find out what happens with if the server or the client or both of them have IPv6 address. Thank you.